Okay, another functions question. So question A is just saying, let's put G into F. So I'm just going to use some slightly different colours to try and help what we're doing. So this is saying, let's put the function G into the function F. So what is my function F? Well, it's 2x plus 5. So I'm replacing x with G of x. That's effectively what that means. We're putting G into F. So instead of having the letter x, we're having the function. So if I do that again, I'll say that f of g of x is equal to 2 multiplied by, that's going to be x squared. I'll put that in red, sorry. X squared take away 2x plus 5. I'm just going to check the marking scheme. I don't think you have to break that out. Yeah, that's fine as it is. The point is that you understand what's happening, and so that's where you're getting your marks from, rather than doing a breakout. So that's your first two marks there, a mark for the notation and then a mark for the final answer. Part B, put an F into G. So I'll keep that in red. I'll say put G of f of x. Very good. So what was my G function then? It was x squared, so something squared, take away 2 times something, okay. So instead of x, I'm going to have f of x. So it's f of x squared, take away 2 f of x. All I've done is replace the x with the f of x. So you shouldn't have any rogue x's, that anything that's an x is now an f of x, in the same way that if I was doing g of 2, I'd take out x and put in 2. So let's write that properly. Let's see, I've now got g of f of x, and that is equal to f of x squared. So f of x is 2x, I'll do that in blue. So f of x is 2x plus 5, and then I'm going to square that. Take away 2 times f of x, which we just said was 2x plus 5. I'll just check, yep, don't have to multiply the brackets out, just one mark for that. So just take your time with your notation. I actually don't think you totally need this first line, but I'm just, showing the marker what I'm thinking, and it just helps you as well. The neater you are, the less you have to make a mistake. So now we're going to do one function take away another function, and write it as a complete the square. Okay, so I think what I'll do is I'm just going to below here break out the brackets first of all. So that's 2x squared take away 4x plus 5. Okay, and then over here, that's the same as 4x squared plus 20x plus 25. If you're not sure at breaking that out, it's just a little table I do. I usually write it down, but sometimes I just do it in my head. Usually I write it down. Okay, so it's 4x squared, that's 10x, 10x and 25. Different people break out different ways, and then you group your like terms, but that's the way I like to do it. And then taking away 4x and taking away 10. So if we group our like terms, we've got a 20x and a 4x. So I'm going to have 4x squared plus 16x and then plus 15. Okay, so that's me just broken out my brackets. So if I was to do the g of f of x, take away fg of x, right, I'll say c then. So I'm doing g f of x, take away f g of x. So that's this first one, so that's 4x squared plus 16x plus 15. Okay. And so that I'm taking, and the brackets are very important here. 2x squared, take away 4x plus 5. Okay, so 4x squared, take away 2x squared, that's 2x squared. 16x, take away negative 4, so I'm adding that, so that's going to be 20x. And then 15, take away 5, that's going to be 10. Fantastic. And it wants it in a complete the square form. Okay, so first thing you could do actually is take out 2 as a common factor if the whole thing, but I tend to just take out 2 or whatever it is for just the first term. I find that an easier way to work. Okay, and that's what this little a term is here. You're just trying to get your x squared on its own, okay? Because now we're going to rewrite this by halving that middle term. So that's going to give me a 5 squared. That's why I want the x squared on its own, because this method only really works if that's got a 1 in front of it, okay? So I'll halve this, and that's all looking good, but if I was to break this bracket out now and add it together, I've actually generated something I don't want. So I need to take away the thing I've generated. If you look, right, if I was to break that out, I would have x plus 5 and x plus 5. So that's x squared, 5x, and 25. And then I'm timesing that by 2. So that'd be x squared plus 10x plus 25 times by 2, which is 2x squared plus 20x plus 50. Now I didn't want all of that. I want this to be the same. Do you know what I mean? I want 2x squared. Yep. I want 20. Fantastic. But I actually don't want the 50, do I? Because I've got the 10. Okay. So I need to take away the 5 squared times 2. I need to take away that 50 that I've generated. So if I take away the 50 I've generated, I'm right back to where I started. So now I can say, right, let's rewrite that. Plus 10 take away 50 is take away 40. So if I was to do this and take away 40, fantastic, yeah, I've got the 10 now, don't I? Okay, so that's how I think about it. Some people, I mean, I could write actually just to be perfect. Actually, what I could write is that I take away the 5 squared multiplied by the 2. Okay, that's what you're taking away. But if you want to try and visualize what you've done, it's because if you break this bracket out, you make this number here, and we don't want that number. Okay, we wanted the x squared and the 20. That was great. Yeah, we wanted that, but we didn't want this 50. So that's why we take that away. So that's your final answer. And FYI, if it was asking, the turning point for this would therefore be -5, -40. Change the sign, stays the same, just in case it was, if it was asking that in the question. So a nice wee question there. You've got 3 marks for the first bit. I'll check my time. Yep, 3 marks for the first bit, and then this is worth 4 marks. So you get a mark for this. You get a mark for your taking out your 2, and then you get a mark for the 5, and then the 40. So pretty good actually. Nice and a nice question. We've been doing that again since 3rd, 4th year as part of National 5. So completing the square really should be there. And sometimes that's tied in with like a differential where it says, what if that was the differential? Say that represents the differential of a function. So if dy by dx was that, prove if your function's increasing or decreasing. Well, you would say, okay, well my function then is doing something like, in this case it doesn't quite work actually. Yeah, in this case it doesn't quite work. But what you're trying to say is that your function is always, if it's always in a positive zone, it's increasing. If it's not, it's decreasing. But in this case, that doesn't quite work actually. But anyway, yeah, that's your complete the square.